Hello, it's dumplet here. Here's an item on geometry. We have 4 parabolas, and in each corner there's a pair of parabola tangent at that corner. Find the amount of the square that is shaded. Credits to Mr. Diego Ratagi for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now in this item, it is almost expected for us to use calculus to draw out or to get a conclusion on what the area is, because we have a parabola and we have some point of tangency, so we can kind of make some use of probably differential and integral calculus to help us solve this item. First, let's try to draw out one of the tangents at, let's just say, this vertex. Let's just say the upper parabola has takes an equation of the form y equals f of x. Then we can kind of draw the conclusion that this point at x equals some value c, f prime of c would be equal to 1. Now this is because of some nice symmetry. We can kind of make the observation that f prime of c is equal to 1. Now this motivates us to plot some points, maybe draw out, maybe set an origin and kind of draw out the area via integral calculus. So let's try to focus on the upper parabola and let's see what we can do with the upper one. So here we have the upper parabola, and I'm going to label the points as follows. I'm going to put the origin at the midpoint of the side of a square, so let this be 0, 0. And as defined a while ago, there will be a value of x equal to c, such that f prime of c would be equal to 1, or the slope of the tangent line would be equal to 1. So we just call this point c comma 0. By symmetry, this would become negative c comma 0. And let's just call the vertex of this parabola 0 comma k for some value of k. Now, writing it in the standard form of the parabola, y minus k would be equal to 4p x squared. Now, let's try to eliminate some of the variables, because since we're just trying to get the ratio of the shaded area to the area of the square without loss of generality, let's just say c equal to 1, because everything can be scaled down, up or down. So without loss of generality, let's just make our life easier. Let's just say c equals 1. All right, if c equals 1, then I will be able to have 1, 0 to be a point on the parabola. So let's substitute 1, 0 into this equation, and I would easily make the observation that 4p equals negative k. So another variable eliminated. So we have y minus k equals negative k x squared. So we have this format, which we can use to kind of help us draw out what is the exact form of this parabola. We have a variable k, and we haven't used the fact that the derivative at c equals 1 now. So the derivative at x equals 1, so the f prime of x, or y prime, here would be equal to 1. So let's try to do that here. So we have y minus k equals negative kx squared. Now, as seen a while ago, we know that the tangent line would be equal to, would have a slope of 1. So f prime of 1, if the graph here has an equation y equals f of x, then y prime of 1 would be, f prime of 1 would be equal to 1. So at x equals 1, y prime would be 1. So we're going to differentiate both sides of this given equation, which is so far the equation of our parabola. So y prime would be equal to negative 2kx, just some simple power rules here. And we know that at x equals 1, y prime would be equal to 1. So y prime would be equal to 1, and x would be equal to 1. We have an equation in terms of k, and we can solve for k. We're going to get that k equals negative 1/2. So we now have an equation of the parabola, the upper parabola, y plus 1/2 equals 1/2 x squared. Now that just came from substituting k into this equation, because now we have k equals negative 1/2, we substitute it in, we're going to get y plus 1/2 equals 1/2 x squared. Now I'm just going to put this 1/2 on the other side. I'll be getting that y is equal to 1/2 x squared minus 1/2. Now, we're kind of interested in getting what this area is because of the following. This area is going to be 1/4 the area of this part, this part, this part, and this part. We can use this to kind of help us get what R is. So we first have to draw out a conclusion that the shaded region, we can use integral calculus for that. That's going to be related to the value, which is related to definite integral from -1 to 1 of whatever this equation is, which we have y equals 1/2 x squared minus 1/2, as acquired from the previous slide. So we're going to integrate this with respect to x and evaluate it from -1 to 1. So we're going to get this, again, just some simple power rules here. And we know that this area can be represented by this. So we evaluate this one, which would be equal to 1/6 minus 1/2 minus -1/6 plus 1/2. Now, if you evaluate this though, you're going to get that the value of this, it's -2/3. You don't have to worry, because it is expected that we get a negative area because we set our x-axis to be this line over here, and the area lies below the x-axis, so don't worry about it. The area is going to be negative. Again, it's below the x-axis, but we need the absolute value of that, so we take the absolute value of -2/3, so that's going to be equal to 2/3. Alright, so this region has area 2/3, and because of symmetry, we have the same thing, 2/3 for all of these. So we can kind of make out the conclusion that, oh, the area, the region R, or the shaded region that we want, that's going to be simply 2 squared. Now, why 2 squared? Because we set the 2 points here to be -1, 0, and 1, 0. So the side of the square has length 2. So 2 squared for the entire area. And then I have to subtract 4 kind of circular sectors, not really circular, but this 4 parts, each with area 2/3. So -4 times 2/3. And you can get that the area of region R would be equal to 4/3. So the last step, now that we have the area of the region R, which is the shaded region at the start, we simply take 4/3, the area of region R, divided by 4, the entire region of the square, and we will get that the amount of square that is shaded is going to be 1/3. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!